Okay, duct ligated tissue as donor pancreas. We've created a donor pancreas whereby the duct of the pancreas is ligated at the tail end, and the tissue after the ligation will generate new pancreas, new islet that produce insulin, just like the fetal tissue. And we take this portion of the islet and transplant it into a diabetic patient to revert diabetes. Then we will see that the pancreas here lies just beneath the stomach. Then our body needs to maintain the normal level of glucose in the body. Then when we eat food, the carbohydrate is broken down into single sugar that goes into the bloodstream. And this sugar, when it reaches the pancreas, beta cells, which is part of the pancreas, will produce insulin. And insulin will serve as the key to unlock the tissues. In this case, you have the muscle here, so that the insulin, so that the sugar can be absorbed by the muscle. Then that is the role of the insulin to balance the sugar level in our body. But what happens if the insulin level produced by the pancreas is low? Then the sugar level will be high in the blood because there won't be enough key to unlock the tissue. The same thing if the insulin production is enough, but there is a problem to unlock the absorption of the sugar, then we still have a high level of sugar in the blood. Then both situation is what we call type 2 diabetes. In type 1 diabetic, what happens is that we may have a little production of insulin, or we may have no production at all. And in that case, the beta cells are completely destroyed due to the antibodies in our system. Then that is type 1 diabetes. Then type 1 diabetes, the only way to resolve this problem of type 1 diabetes is to transplant islet cells into a recipient. But the problem we are having is that we don't have donors. It's very difficult to have donors. That's why we created our own model there. But for us to use our model into a human, we have to answer two questions. Where are those new beta cells coming from? The formation of the beta cells, are they the same as the beta cells in nature? Then we did the mapping, the gene mapping, to see if the genes that are expressed in the normal development of beta cell are the same that are expressed when we do the duct ligation. And in fact, the gene expression are the same. Then, to resolve the problem of where are those beta cells coming from, then we try to follow up as the gene are expressed. We could see that there is a particular cell here that is called the acinar cell. Those acinar cells are formed following the interaction between the pre-existing beta cells and the mesenchymal cells, which is an adult stem cells. Then the interaction will create the formation of the acinar cell that will give rise to the islet cells. And those islet cells then are the ones that we use to transplant into the diabetic recipient. And that is what we discovered. Thank you.
So you're saying that you've discovered a way of using live people to donate their beta cells to diabetic patients rather than wait for somebody to die and transplant their pancreas?
Yes.
Okay.
Yes, just by ligating.
But what does ligation mean?
Ligation means that we tie up the duct.
Okay.
Just like I showed in the first slide. Yeah, we just this is the duct, this is the pancreas. And we have duct inside the pancreas. then we just ligate this tail end. Because we cannot ligate it here. It may damage your whole
Okay, so
tissue.
I could donate beta cells now with this method.
Yes, we just ligate just this portion and collect the tissue, the new ones that are here.
But what is the risks for the donor? That's the first question that would come to my mind.
The risks?
Risk for the donor. What is it? Do I have to get anesthetic? Can it damage my health in any way if I donate it?
Not really, not really.
Would you require anesthetic?
Yes, of course. To do this will be a biopsy, but to ligate the dot, we have to give anesthetic to the patient, to the person who is donating completely. Yeah.
But I understand you haven't tried this on humans yet.
No.
So
This is just.
On what have you tried it?
Hello?
On what have you tried it?
Animal.
Okay,
Yeah.
that's important.
And it
to say.
works.
Yeah.
It works. Yes.
Yeah, it works. That's why I say to try in human, we have to do the gene expression
Yeah.
to make sure that the genes that are expressed are the same and to
Yeah.
see where they are coming from.
But it's basically new hope, but it's still a little bit into the future.
Yeah, yes.
Because that's the one thing I wanted to say right at the beginning, before you explain type 1 and type 2 diabetes, I would right at the beginning, I would say something like, diabetes is this huge worldwide escalated problem, but there's light at the end of the tunnel. We've got exciting results that, and you don't have to say what yet, but we think that we may be working towards a solution. Then you can explain and then come back to, but right at the beginning you've got to give us that idea that you are so excited because there's something promising that or emerging, and then you know what I'm saying?
And your headline. If
Yes.
you go back to your title there, ligation, duct ligated tissue as donor conquered. Ligated, nobody will understand what ligated. We didn't understand it. So just
make it.
get a common word.
Or new hope for diabetes.
My title I wrote here is Hope for Diabetics.
Yeah.
Something, just
Or something like that.
it's going to take some thinking. You're going to have to brainstorm this
Yeah.
with friends and that. But something like, diabetes patients, or new hope for diabetics with just a tip of the pancreas or something like that. Lying waiting at the tip of the donor pancreas or something like that. But the whole idea, because if I understand correctly, typically it would be like the way you have organ transplants, it would be a close family member. It would have to be somebody that's very compatible.
Yeah, it can be somebody, or it can be the person himself.
Okay.
It can be the person himself that does not have tissue that are functioning. But by ligating the duct, is triggering the new formation of, it can be a native, the person himself.
So it's not a transplant, it's a...
It may not be the transplant, it may be the person himself.
But it could also be a transplant.
Yeah, it could also be a transplant, without looking for a person
But that's
ready.
very,
Let me give you an example.
I got the just NRF grant for this.
Remember yesterday I told you Haldane's phrase, everyday experience, bring it down to everyday experience. Closing the tap can save diabetes. Because that's what you're doing, you're closing a tap. In some sense by tying off a tap. Isn't that so? So try to make it relevant in everyday life. You understand what I'm saying?
Yes.
I like this very much. It's just these little tweaks you have to do.
Doing that, what I think is important to understand is it doesn't, even as we're sitting here now, we can't come up with a perfect title for you. It's going to take some thinking and refining and trying out different titles, and then also, experiencing with how you can really make the story easy for people to understand. And my recommendation for you would be, work on it some more based on what we said now, and then go try it out with people who are not in your field, maybe a cousin, a neighbor, friend, whatever, and see if they really understand it. So try it out again and again if you're actually going to present it to a general audience. But it's amazing research, it's fascinating. So
Afsit om je aan te
I think